Alright, folks, welcome back. So, like I had mentioned at the end of the last video, we're going to pick right back up with VRF and peering BGP, eBGP between the endpoint customers, which in this case is Cisco on both sides. Alright, so let's start on router 1, and we're going to go ahead and we're going to define that virtual routing and forwarding instance. So to do that, we type VRF definition, and you can see it wants a name. So we're going to call it Cisco, okay? And you have to tell it a couple things. You have to give it route targets. So in this case, I'm just going to say the route target is 65,000 colon, I'll just call it 1. We'll overcomplicate this in a little bit of a, we'll somewhat overcomplicate this, but for good reason. I just want to show you in the future why these route targets are important and how they come into the picture. So we'll say route target is 65,000 because that's Cisco's Site A autonomous system number, and we'll say colon 1 just because this is Site A and it's easy for me to remember. It's a 10.1 subnet, so we'll just call it that. Okay. Sorry, you got to do the route distinguisher first. My apologies. So we'll say 65,000 and we'll say 1. Okay. Then we can type the route target. Okay. So if we do show run section VRF, we can see that we've got this VRF defined with a route distinguisher and route targets that are set to export and import with this syntax or this, route distinguisher, if you will. Okay. So let's go to router 3 and let's create the VRF over there. But in this case, we're going to say it's 65,000 colon 2, okay? Because remember, our site B has the second octet is defined as 2, so let's just call it 65,000 colon 2, okay? The route target, we're going to say, I said both, right? Yeah, okay. Yeah, it sets it for import and export, which is essentially both, right? So we're going to do 65,000 colon 2, do show run section VRF. Okay, good. So we've got our VRF defined on router 1 and router 3. So now what do we have to do? We have to do the peering between the service provider router and the customer router. So we know that that's off 0, 0. So let's go jump over to E0, 0. And the first thing we need to do is we need to tell this interface that it should be participating in VRF Cisco. So basically you say IP VRF forwarding, okay? And then you would say IP address, or we can say a couple things here. So that's not the right command. We say VRF forwarding, my apologies, and we say Cisco, okay? There's an old way to do VRFs, and there's a newer way. The newer way is with VRF definition, which is what I did. The old way, it adds IP VRF forwarding versus just VRF forwarding, so it couldn't be any more confusing, and it's just one more thing to have to try to remember. But anyway, at any rate, because you can see when I typed IP, where was it? When I typed IP VRF forwarding, it dumped me into a different mode, which that told me right away it was the wrong command, versus when I did VRF forwarding, it left me in interface configuration. So this is the one we want. So if we do show run interface E00, we can see that it's in VRF forwarding, there's no IP address, and it's shut down. So let's give it the IP address. So we're gonna have to do a couple things here. I'm just gonna probably reuse, actually no, I'm sorry, we're gonna use the 192, right? So let me just double check something really quick. What address did we have prior? So we had that 192.168.1.2. We're gonna steal that IP address back, okay? So right now it's on 2, because remember a few videos back we had simulated a basic MPLS. So let's just go ahead and let's default let's default interface E02, okay? Because I want to essentially use that IP, but put it on 03, okay? So he's ready when we're ready to hop over to him. So IP address should be 192.168.1.1, all right? Yeah, 1.1. So we'll make it a /30, okay? Enable IPv4. Oh, I forgot a command. Man, it's been so long since I did this stuff. Jeez Louise. Definition, Cisco. And we gotta say, I knew I was forgetting something. What is, oh, address family, IPv4. That's what I forgot. Let's do that on router 3 as well real quick. I'm sorry guys, I'm told you I'm fumbling through this stuff bad. But hey, that's why we're doing it live. This is not only a test for me, but kind of a fun process for everyone, I guess, right? Address family IPv4. Okay, good. Fun. So now when we go back to interface E00, okay, do show run interface E00. Now if we go to put the IP address on there, it better take it. 1.1/30. That's better. Let's no shut him. We can give him a description. We can say customer Cisco site A. Fine. Okay. Okay, good. So we've got the IP address. It's participating in the VRF. If we do show VRF, we can see that we've got Cisco. We can see the route distinguisher. It's participating in IPv4 and it's attached to this interface. For VRF, is that it? Okay, fine. You get in the habit of, when you do a show IP interface brief, you see these interfaces with IPs, but you don't really see that they're in a VRF. So it's not a bad habit to get into to essentially do a show VRF just to see, because you can see by that command that it is attached to 00, but the show IP interface brief doesn't give you any indication of that. So you got to kind of start to be aware of this kind of stuff, like in production environments. At any rate, let's go over to the Cisco's router 1. All right. So we had removed the 192.168.1.2 from 02. We're going to essentially move that over to 03. All right. So let's go over to E03, and we're going to give it a description. This is MPLS. What did we say before? 1 gig MPLS or something like that. So that's fine. Okay, and then we're going to say IP address is 192.168.1.2 should be us, right? /30, and we'll no shut him. Now, I believe we still have the static route. Yeah, we still have the static routes. So this static route, in theory, still works for the moment. When we do BGP peerings, we're gonna want to get rid of this. For the moment, it's fine. We'll leave it. All right, but we won't need this once we start doing the protocols, which you'll see. This is gonna be next video. So let's just do a basic verification. So show IP interface brief. We can see 1.2 is now on Ethernet 03, and one key point here is this router has no VRFs. There's no reason to have VRFs because it's Cisco's router and it's only Cisco. They're not offering services to other customers. The service provider is the one who potentially has multiple customers hanging off one router. So that's the reason for VRFs there, and that's the reason you don't need VRFs here. That's not to say that you may have an instance where you need to run VRFs, and if you are managing a single company, there are reasons to do that. But in this particular case, there's no legit reason to have to do that, okay? So now, check this out. If I show IP route on the service provider route, we can see that we only know about the 10 dots. So you might be asking yourself, well, how come I don't see the 192 address? Well, it's because we put it in a VRF. So in order to see those routes, you have to say show IP route, VRF, and the name of the VRF. So now you can see this is a clear example of how the VRF took the routing table and essentially split it in half or segregated, however you want to look at it. They're two different, totally different routing tables at this point. So we can see that we've got the 192.168 address that's connected on our interface 00 that's going to Cisco's site A. Now, if I try to ping 192.168.1.2, this is not going to work, okay? Because we're saying ping 192.168.1.2, but we didn't tell it the VRF, okay? So as soon as you start introducing VRFs, you'll find that a lot of the commands you have to run involve the keyword VRF. So if I try to do that ping again, but I have to specify the name of the VRF. So ping VRF Cisco 192.168.1.2. Let's see what happens here. Look at that. So we've got connectivity over to the Cisco site through the VRF Cisco. Okay, so that's a great sign. Let's just make sure that we can ping 192.168.1.1 from here. We can. So life is good. Okay. So all we've done is we've turned up a 1 gig MPLS circuit between us and the service provider, same as we did here, okay? But keep in mind, there's still some work we need to do here to get the routes to go from side to side. But that's going to be for the next video. So what we're going to do is, just to keep things consistent, we're going to go over to site B. So let's go ahead and let's take default 02, okay, because we're not using that right now. So default interface E02. We're going to go into E03, and we're essentially going to move that IP address. So description, 1 gig MPLS, IP address 192.168.2.2. That's a /30, and we'll no shut him. Okay, so he's ready. Let's go to service provider router 3. Okay, we've got the VRF. But now we've got to attach it to 00. Okay, we haven't done that yet. So we come over to E00. We say VRF forwarding for Cisco. We say description. What did I give this one? So we're gonna steal this, except it's gonna say site B. Okay, and we're going to give it the IP address 192.168.2.1 in this case, and we'll no shut him. So same story. If we show the IP interface brief, we've now got 2.1 attached to this interface. We don't necessarily see the VRF attachment there. We've got to do show VRF. Now we can see that VRF Cisco with its route distinguisher is essentially assigned to E00. So let's try to ping. See what I did there? It's a habit. It's a bad habit that we have to break. Ping VRF Cisco 192.168.2.2. Okay, we can see that the ARP went out, and then we've got the 4 pings back. So at this point, we should have full connectivity. So if we go to BR1, we should be able to ping 192.168.2.1, which we can. Okay, so we're in a good spot. We are going to break here, and then hopefully in the next video we will introduce the advertise. I'll show what the tables look like in router 1 and 3 right now. We'll introduce the exchange of the routes for the 2 Cisco sites, and we'll see if we can get full connectivity end to end. So that's going to be next video. So can't wait to see you guys there. Stay tuned for that.